Hello, Tom again from everystepcalculus.com, everystepphysics.com. I'm going to continue my series of videos on these trig substitution and how to do this step-by-step series for these integrals here that we look at on the screen here. Number 3 is what we're doing today, or in this video. And so let's do it. Index 8 to get to my menu. I'm already at u-substitution. You'll scroll down to that. Press alpha before you enter anything in here. You enter all these characters here just like you would in the home screen of your calculator. But you have to press alpha first with mine. I've already entered it, so here is the integral, or the function. I say it's okay. I give you a chance to change it in case you made a mistake, but I say it's okay. And first thing I want you to know that there's a squared is 9 here, and these could be 25 or any square, 16, 25, 36, 4, any square would show up in these problems. They're set up problems. That's the reason the calculus never solves anything useful, because they're all set up and ridiculous puzzles that we're supposed to answer in our tests and make us miserable for that semester. And of course the pretext of the professors say that you can solve all kinds of things. You can't solve anything with calculus useful. After 25 years of me programming this stuff, every single comma, every single period, whatever is required to program it. So anyways, here's the function. I've placed the dx over in the numerator here because if you have 1 over there and the dx over here, you're really multiplying times 1 times dx, so the dx can go in the numerator here. And here's the denominator. So we let x equals a sine of u, okay? And then the derivative of that, differentiating both sides of the equation. We got 1 dx and we got a cosine of u du. Okay, and then we square the x squared just to clean up some things before we get into the actual problem. So you write that on your paper, get it all set. We're going to figure out what this is now with substitution. And you notice that the 9 is a squared here, and then minus x squared, which we just figured out, which is a squared times sine squared of u. We factor out the square root of a squared to clean it up, and we get this 1 minus sine squared of u. This is all designed to go to an identity, which is the Pythagorean identity. And in the next screen I show you that. And here you have cosine squared of u, and plus sine squared of u equals 1. So when you use algebra to put the sine squared on this right side here, you get cosine squared of u is equal to this. Well, that's just what we found in the previous screen. So therefore the square root of 9 minus x squared is equal to a times cosine of u when we do the math. Okay, so we can remember that. Here's the dx and the problem we're working on. And we're going to substitute these values. We found out the x squared, we found out the square root of 9 minus x squared, and we found out the dx. So we're going to substitute those in there now, which is what you see on the screen here. Notice that a cosine of u cancels out because of algebra. So we have du over the a squared times sine squared of u. We bring out any constant before the integral sign, of course, and of course this is 1 over 9, so we bring that out in front of the integral. Then we're left with 1 over sine squared of u du. Well, 1 over sine squared of u, which is an identity also, is equal to cosine squared of u. And we have the constant outside the integral sign, okay? And the derivative of, or the integration of cosecant squared, is equal to cotangent u plus c. minus cotangent u plus c. And cotangent u is equal to cosine over sine u, so we put that in here, minus 1 over a squared times cosine u over sine u plus c. And we figure out what sine u is, which is equal to x over a, because here's x equal, we did this at the very beginning, remember that we made x equals a sine u. Well, we transfer the a to the other side, and here's what sine u is equal to, x over a. And we found out that 9 is minus x squared is equal to a cosine of u, and so cosine of u is equal to square root of 9 minus x squared divided by a. We used our algebra knowledge again, and we start putting in the numbers back in and the a's. Okay, so we have minus 1 over 9 times the square root of 9 minus x squared over a over the denominator x divided by a plus c. So the answer is minus 1 over 9 times the square root of 9 minus x squared over x plus c. Just like this answer here, okay? So go to my site, buy my programs, and have a good time passing calculus. Otherwise, study this stuff for weeks like I do to figure out the insanity of all of it and figure out the steps. Notice how much you'd have to memorize for one problem that might be at a test, okay? But you have other classes and you have many other problems to study, so it's kind of depressing when you get into calculus, because it's really a language. You're trying to memorize all kinds of different things, new language to learn, and at first nothing makes any sense, and nothing really makes any sense ever in calculus. So enjoy my programs if you want to buy them and pass calculus. Good luck in your classes. Have a good one.